A pleasant good afternoon to everyone. My name is N. Pawan Kumar. I am studying first BTech semester in SRIT College. Today I am here to say about ionic polarization. Introduction to ionic polarization. Ionic polarization refers to the distortion of electron clouds in ions when subjected to an electric field. This phenomenon occurs in ionic compounds and is significant in understanding their property. Here, ionic polarization includes various physical characteristics such as melting points and solubility. Basic concepts of ionic polarization. Ionic polarization is primarily caused by the presence of an external electric field. It occurs when the positive and negative charges within an ion are displaced relative to each other. The degree of polarization depends on factors such as the size and charge of the ions involved. Mechanism of the ionic polarization. The mechanism involves a shift of electron density in response to an electric field. Anions or negatively charged ions are typically more polarized than cations. The polarization effect can create temporary dipoles affecting the overall charge distribution. Here the picture of mechanism of ionic polarization. Factors affecting ionic polarization. The size of ion plays a critical role in determining the polarizability. Large ions tend to have more diffuse electron clouds, make them easier to polarize. The charge of the ion also affects polarization. Higher charges lead to strong electric fields. Ionic polarization in ionic bonds. Ionic bonds are formed between cations and anions and influenced by polarization. The distortion of electron clouds can lead to partial covalent character in ionic bonds. The partial can affect bond strength and stability in ionic compounds. Here is about the picture of ionic polarization in ionic bonds. Polarization and lattice energy. Lattice energy is the energy required to separate ions in a crystal lattice. Ionic polarization can reduce the lattice energy by stabilizing the ionic arrangement. A higher degree of polarization generally results in lower lattice energy. Here the polarization lattice energy. Lattice energy is the energy required to separate ions in the crystal lattice. Ionic polarization can reduce the lattice energy by stabilizing the ionic arrangement. A higher degree of polarization generally results in lower lattice energy. Now, effects of ionic polarization on solubility. The degree of ionic polarization can impact solubility of ionic compounds in solvents. Polar solvents can effectively stabilize the polarized ions, enhancing solubility. Conversely, non-polar solvents may not interact favorably with polarized ions. Applications of ionic polarization. Ionic polarization is a empirical design material for electronic and optical applications. It helps us predicting the behavior of ionic compounds in various chemical reactions. Understanding polarization assists in developing better catalyst parameters. Ionic conclusion. Ionic polarization is a fundamental concept in understanding the ionic compounds and their interactions. Its applications range from chemical reactivity to material properties in different fields. Continued research on ionic polarization can lead to advancements in various scientific and technological fields. These are the pictures of the ionic polarization. Thank you and have a nice day.